The tracking signal of a forecast is essentially a ratio. You calculate this ratio in order to, in essence, score the forecast. This particular question is asking for exactly that calculation. Now, wait a minute. What exactly is this ratio? All right. We need to remember that the tracking signal is the sum of the forecast errors divided by the MAD, the mean absolute deviation of a forecast over a certain time period. Now, the problem that we're working on says, given forecast errors of 3, 2, -2, and 9, what's the tracking signal? We need to fill out that particular formula. Oh, okay, so in order to fill out the formula for the tracking signal, you have to first calculate the MAD, which in a certain sense is another formula. Now, the mean absolute deviation, you can think of it as a formula. We could make a little workspace over here. Mean absolute deviation equals sigma for sum of the absolute value of the errors, that's what the two vertical lines mean, divided by n, the number of periods. But I find that it's just easier to remember what that phrase means than to remember it as a formula. Mean, average, absolute deviation. What is the average absolute error? Oh, okay, so for this problem, there's these 4 forecast errors that have been volunteered. The absolute errors are those same numbers, except you would drop any negative signs, like for instance right there. Oh, so that means that the mean absolute deviation is the average of 3, 2, 2, drop that particular negative sign, and 9, divided by 1, 2, 3, well, there's 4 periods. The mean absolute deviation here, let's see, that all adds up to 16, comes out quite evenly. 16 divided by 4, or 4. Oh, now we need to remember that that's an intermediary step, right? Because what we were trying to calculate was the tracking signal, and basically what we found there is the denominator. So in the tracking signal, the numerator is the sigma sum of the errors, the sum of the errors, not the absolute deviations, just the flat errors. So 3 plus 2 minus 2 plus 9. Well, 3 plus 2 minus 2 plus 9, I get that's 12, again divided by 4, or 3. The tracking signal for that particular set of 4 errors is, that's the answer to the question right there, is 3. Now the next question also concerns a set of forecast errors, and one of them is negative. Oh, and it then gives us the actual values over those same time periods right here. And it asks for, wait a minute, what is the question? The mean absolute percent error. This particular question, it helps to organize it vertically. I'll show you in a second why. And the way to get this answer, what I recommend is to break it down. Mean means average, absolute means drop the negative signs, percent error. The percent error in a forecast is the actual error divided by the actual. Oh, right, we were given errors. List them this way: 10, -2, 25, and 0, 0. Okay, those are the errors. Fine, we were given actuals, list them in a column. Because what I want to do is say 10 divided by 120, -2, that was the error, divided by 145, 275, 124, divided by. Why? Because first I'm going to calculate the percent errors, and that would just be if I put those into the calculator. Right, so for instance, 10 divided by the 120, I get like 0.83333, some odd. -2 divided by 145, I get a -0.1379. 25 divided by 275, 0.0909, and then 0 divided by 124, that's going to come out to 0. All right, these are the percent errors. Now, next step, that's just this part right here. Absolute percent errors. Just drop the sign, 0.0833. The only difference would be this one right here, 0.1379, the absolute value of negative 0.1379. The absolute value of 0.0909 is just 0.0909. There's nothing to drop, and same thing in the case of 0. Now we're trying to calculate the mean absolute percent error. Mean means average, so we just want to average that column. Average those four numbers together. When I averaged them together, I got 0.047, and that is known as the MAPE, mean absolute percent error, or in conversation, 0.047 or 0.47%. That's the answer to that question.